If you want to email me or get in contact with me, as Allison said, I do own the domain don'tusethiscode.com. The reason I bought that domain was that I wanted to make the disclaimer very obvious when I post ideas for people to use. On IRC, my IRC handle is DUTC, and people in the Python channel will ask questions, which are like, how do I do this really stupid thing? And I'll say, well, this is how you do it. And then some people say, please don't show the newbies how to do that. And I'll say, well, yeah, but I'm DUTC. Don't use this code. Now, one comment is sometimes on IRC people will be typing really quickly, and they'll put an H on the end. They'll think I'm Dutch or Dutch. And we did find a way to fit Dutch into it. So if you ever accidentally call me Dutch, it's okay. I'm from Texas. That stands for don't use this code, HOS. Okay, at least a little laugh out of that. Additionally, the reason I got that domain was so I could create a blog at seriously.don'tusethiscode.com. I haven't updated it in a while, but I'm planning to add a couple more posts. But there's a lot of really weird and wild and wacky stuff, and a couple of things that you might see tonight. With that said, we're going to jump into the presentation. And I'm going to do it kind of Mr. Rogers style, so I can play on the computer while I present the slides. I use a window manager called Awesome, and I don't like slideshows. So what I do when I give presentations is I create virtual desktops, and I use the names of the virtual desktops for each of the sections of the presentation. So these are the sections you're going to see tonight. It's going to go from me, then bad, then worse, then awful, then stop, then evil, then stop, then frowny face, and then we're done. So I'm going to show you about 7 things that you really shouldn't do, some really wild and wacky stuff. Trust me, I don't have anything better in my life to do than to come up with these ideas. And I have more, so if you're interested in more, send me an email, james@nycpython.org or james@don'tusethiscode.com. Let's get started. On my blog, I had one topic that I really liked, which was bad answers to interview questions. And I think there are 2 really common interview questions that people ask. The FizzBuzz question and Pascal's triangle. For FizzBuzz, it is print out a list of numbers from 1 to something, and if the number is divisible by 3, print out fizz. If it's divisible by 5, print out buzz. And if it's divisible by 3 and 5, print out FizzBuzz. And this is a basic test to see if people can understand how to write if-else clauses. Well, I decided, could we write a generalized FizzBuzz in a single line of code? So this is what it looks like. And you can see this FizzBuzz will take any set of terms, and it's generalized, and it's actually an infinite sequence of FizzBuzz terms in one single line. If you really look at this really carefully, you can see I use 3 pieces from, I use a lot of iter tools in these crazy things. So I use combinations in here. I use chain dot from iterable. If you ever work with me and I say we should use chain dot from iterable for this, you know something is amiss. And you actually pass in the terms which you wanted to run. Additionally, for Pascal's triangle, I thought, well, maybe we can do Pascal's triangle in a single line as well. So here's kind of the extent of what you can do in a single line. There's actually one very common pattern in here that comes up a lot in my code, which is a pattern called endwise, which is in a single line of code, can you write a generator that gives you pairwise views of a sequence. So you have a sequence from 1 to 10, and you want to look at 1 and 2, 2 and 3, 3 and 4 in a windowed fashion. And it turns out I've written this enough times, and I could probably write it from memory. So it looks something like this, from collections, from iter tools, import islice, t, and izip. And it looks like this. It's a really useful one, g, n, izip, star, islice, g, from none, also from I to none, or I, G, in, enumerate, T, G, N. So you can see, Python is well known for a language that tends to be very easy to understand. But if you want, you can also make it mostly inscrutable. To this extent, one project I've been working on off and on is to see how much can we really stick into one line. Because you can think for a for loop, if you have multiple statements, you need to put a new line in. And so you can't do it in one line. Also for try except. So one project I've been working on is this. Things like how can you condense common patterns in Python to a single line. So this is an example of how you can take this try except pattern and write it in a single line. So this is what a try except looks like in a single line. And it turns out that it actually works, with the one exception that you can't get the value of the actual exception object. Don't pay too much attention to this, because really, please don't ever do this in practice. It's just a little toy. So that's bad. It gets worse for you. That's the first one. Here is worse. So Python 3.4 introduced a new keyword, yield from, or an amendment to an existing keyword, yield from. And one thing that Python is also well known for is a very regular and very understandable syntax. Namely, you can't do a lot of weird stuff with the syntax that you could do with maybe a language like C++. However, you can still do some pretty wild stuff, combining features. So one day I decided to combine a generator expression with yield from, and I ended up with this. None for G and G if yield from G and false. Does anybody know what this does? So the good news is, it's the exact same thing as this. X for X and X for X and X. So it turns out that these are both two ways to take a list with one level and a flat net. And it's the exact same thing as chain.from iterable. But it goes to show that if you are really perverse and you really try, even with a regular language like Python, you can abuse the syntax and come up with some things which are totally inscrutable. I've shown this first one to a couple of core developers, and even they were a little bit stumped as to what it did. So Python, if you're evil enough, you can do it. And that's my overarching message for you guys tonight. If you're evil enough, if you have enough pure evil in your heart, you can destroy the world. Let's go on to offer. So I started playing around inside the Python interpreter. And one thing I noticed was when you use a decorator, you have your @ sign and then you put a function in. But there's a limitation as to what you can put. And inside the Python source code, there's a file called grammar/grammar. And that defines the grammar of Python. So I thought, what's a really simple thing we could do to change the grammar of Python? Well, it turns out with 3 one-line changes to the Python interpreter, you can remove this distinction from decorators. And you end up with this. You can actually have like a lambda decorator. You can have any arbitrary expression as a decorator. So you can have like an and or expression you can index into a dictionary. And I did this as part of a workshop that we held last year that was going into the beginnings of the CPython interpreter. And during that workshop, we actually submitted this as a bug to the bugs.python.org. And we got a little bit of feedback. Guido said, please no, but I don't care that much. And then some other people said, create a pet. And I think it's been a couple of months, and we haven't really created a pet. But maybe one day, you'll actually be able to do this, and it'll be because of me. And you'll see somebody who's written code like this, and you'll have me to thank. One day, Andy's here tonight, one day, I was a little bit bored, and I was chatting with Andy, and I accidentally typed in my interpreter a return statement at the wrong level of indentation. And we all have probably seen this error before. You do return like that, and it says return outside function. Well, I searched through the CPython source code for where that was, and I commented it out, and I recompiled, just to see what would happen. And when it turns out you can do that, everything just works. And so you can end up with something like this, which is you can have return functions, you can have return statements anywhere you want, and you can put them in classes. And the really neat thing is, the body of a class is actually a bit of executable code. And what it produces is the dictionary of the contents of the class. So what you could actually do is you could use a class like an anonymous namespace, or just like an ad hoc namespace. Where you do a lot of computation, you can explicitly export the parts of the class that you want to export. So the class might be able to see internal parts or private parts, but you wouldn't be able to visualize them outside the class. So that's something you can do. Why would you ever want to do this? I don't know, but you can. Let's go on to stuff. So I've given a couple of talks in the last few years. Last year I gave 15 talks at 7 conferences in 5 countries. Nobody ever asked me what countries, and I'm trying to bait you guys to ask me what countries. I'll tell you what they are. Canada, the US, Finland, Spain, and Texas. I wish, every time I come back to the US after flying abroad, I wish the passport guy in New York or in JFK will ask me, are you an American or what country are you from? And I have a response plan. If he asks me, are you American? I'll say, no sir, I'm a Texan. And if he asks me what country I'm from, I'll say, I'm from Texas. And then promptly I will be denied entry into my own country. With that said, one of the presentations I like to give is on generators. And there's a lot of weird and wild and wacky stuff you can do with generators. Here's an example. I call this stop because please don't ever do this, but you can and it actually kind of works. In about 20 lines of code, you can see this, we're already down to 693. So this is 20 out of 600 lines of really bad ideas. You can create your own type system on top of generators. So you could do something like, let's go, oops. Let's get down to that. That would be past it. You could do this. You can create your generator objects, and you can put a little tag on them, and that tag is a type. And using that, you can implement something that I called cooperative multiple dispatch. Namely, generators, by virtue of being lazy, allow you to see the entire sequence of a computation. So when you call function after a function after a function, the outer functions only see the result of the inner function. When you do a generator like f, a g, and h, and you compose them, each generator sees the other generator, which means the outermost generator sees the entire computation. As a consequence, if you can add some typing and some dispatch, what you can do is you can do automatic optimizations on top of sequences of generators. Or, in this example, keep losing my place. In this example, I have f, g, and h, and some of these generators are tagged in such a way that if they see each other next to each other, they'll align themselves. So in this computation, f, g, and h composed will result in only one of them being called. Or if you think about it another way, if you constructed your computation as a section of generators, the generators could see each other and then remove redundant computations. They could swap themselves out for optimized versions, so f and g could swap themselves out for a combined fused fg, do all sorts of weird stuff. And it turns out it only takes about 20 lines of code. So that's something that probably please don't do, but you can actually do a lot of these kind of things in Python. You can create your own type systems, your own runtime type systems using instance check and isInstance. You shouldn't. This comes up a lot on the Python IRC channel. It's a really terrible idea, but you could, and maybe it might be a good idea sometimes. But probably not. Let's go on to evil. This is a talk that I gave a long, long time ago. And I have two files here. One is called diff import Python, and one's called diff import Python. And the reason I named these was I have a friend who is another speaker. He's speaking at PyGotham. He'll be speaking at PyGotham this weekend as well. And he once asked me if I ever had a bison burger. Except unfortunately my friend is from Spain, and I couldn't tell the difference between him saying a bison burger and a Python burger. So I came up with this to make fun of him. I'm not a very nice person. But you can see these files are exactly the same. They import something from this module called diff import, and they print it out. So you'd think, if I were to run these files, they should print out the same thing. But no, they don't. It turns out, in Python, there's a really nice safety valve called import hooks. Now with import hooks, you can write an import hook where when you import something from my module, I'll give you a different answer depending on who you are, or depending on what I feel like. So you could be sitting at your terminal saying, from James, import something like that. And I'll give you whatever answer I want to, and different answers at different times, to really, really drive you crazy. And it turns out that's really easy to do. It only takes you 51 lines of Python code. So, I actually initially intended this so that you could embed other languages inside modules, so that you could have a single Python file that embedded another language, and then would interpret it and run it, and then make the results available to the Python interpreter. That unfortunately turned out to be a little trickier than I thought. But I thought it was an interesting thing where you can create modules that return different results with no apparent reason why. And I worked on some mechanisms by which to affect them so that when other things imported from, you import into a module B, and then when you import from that, it will continue the infection throughout the entire system. So that's one thing you can do, and it's kind of evil. And there's actually one use case that I've seen where this is kind of useful. You have a bunch of different modules with a common dependency in your system, except one of the modules is dependent on version 1.0, and the other one's dependent on version 1.5. And what you can do is you could have the module that depends on 1.5 get the code that's different between 1.0 and 1.5, and the one that's dependent on 1.0 get the code. So you could do some very surgical, what's a better word for hack or workaround, or please don't ever do this, very surgical fixes in your code using this mechanism. So, we're almost done. This is my stop tab. And I like to show this GIF because it reminds me of how you should be feeling just about now. Let's get this up. So, that's you, and then please stop. So, I'll show you the stop thing you should do. You know how Python has explicit self? Meaning when you're writing a Python class and you want an instance method, you type def foo self blah blah blah. I always thought that was kind of lame. And I thought, could you have that self somehow materialize without you having to type it? And it turns out there's a couple of different ways to do this. I tried a couple of different ways using eval and automatic generating code. But I thought the neatest way you could do this is this. When you have a name being loaded in the context of an instance method, it will first try to determine if that's a local variable or a local name, whether that's a name in the closure or whether that's a name in the global scope. If it's a name in the global scope, that's kind of difficult because there's only one of those available. If it's a name in the local scope, you need the parser to know that it's in the local scope. You need to inject it to the local scope. And that's very difficult to do. But in the closure, sometimes you have instances where in that inner method, you're able to access names that are defined in an outside function, in the closure. So I thought, well, maybe you could inject self into the closure. But it turns out you can't, because function closures are read-only. Unless you use C-types to go into the currently running interpreter and you toggle a few bits, so you can change the currently running interpreter, so certain things that are otherwise read-only are now read-write. And that's what this does. So here what I do is, I think it's this one. No, it's actually the other one. This is one of the other steps. So let's see, scratch. I have this folder, look, I have this folder full of these. So let's see which one is here. These are all the bad ideas that I could choose from. It should be bytecode 1. Yeah, it's this one. So you can see I stub out all of the Python object, and then what I do is I go in there and I grab the Python object and I fiddle a couple bits. And then once I've done that, I can write a simple decorator that gets the bytecode and swaps out any load global for a load from closure or load deref. And once you do that, you can write code that looks like this. This guy right here. Where you can see it's using underscore self underscore, but that hasn't been defined anywhere. And it's been injected automatically into the closure by means of this decorator and a little bit of interpreter add. One thing that I've thought of doing was, if you really wanted to, you could maybe find out. So one thing, I was in an IPython notebook recently, and I spent 20 minutes loading a huge amount of data. So I couldn't restart the notebook, so I'd have to spend that 20 minutes again reloading all that data. And I had accidentally done from future import print function. So every time I wanted to print something, I had to put parentheses around it. And that really bugged me. And I wanted to see, could I unimport the print function? Could I switch the behavior back to print without the parentheses around it? Well, so I started to look into the Python interpreter to see if that's possible. And it turns out I don't believe it's possible, because there's no hook that you have without a debugger into the future flags that are set on the compiler. But this is a similar idea to something else that I've been trying, which is you might be able to make modifications, monkey patching, to the core mechanisms of the interpreter by getting a handle onto the functions and then going into them and putting little assembly stuff so they jump somewhere else and then they jump back to you. And this is part of the next idea I have, which is to build a perfect proxy without any C code, without any interpreter patching, which would actually have to patch the built-ins that you use, irrespective. And you couldn't patch the built-ins by overriding it, because somebody else might have gotten a handle. So you'd actually have to go into the C code that your built-in is using and patch the assembly. So that's something that might be in a future talk of this nature. But you can see you can kind of do these things in Python, and surprisingly enough, this works on any Python 2.7, Mac, Windows, OS X, it all works. The only thing that it won't work on is if you're using a Python where the format of the Py object has changed, which means you're using Python 3 instead of Python 2. This will work for Python 2, 4, 5, 6, 7. So let's go to frowny face. And this one's a real frowny face. This is a real. So I gave another talk called Embeddings of Python. And I was at PyCon Sweden a month or two ago, and I was going to give my talk, and I recently backed up my computer, and I forgot to transfer other files over. So it was a day of the talk, and I sat down and I put ls on my directory where I keep this talk, and you can see what I found was all that red means broken symbols. So it turns out I didn't have any of my talk with me, and I was a couple thousand, hundred, some distance. I'm from Texas, I don't know distances outside the US. But I was some distance away from home with none of my code. So I had to rewrite this entire thing from scratch. And I was able to do that, and I was able to come up with what was a really interesting and very simple approach to a problem that nobody has. So, we know that we have extension modules in Python. So you can write in C, you can write an extension module. And that extension module can do whatever you want. We also know there's this thing called the very high level and the pure embedding in Python, which means you can have a C program and you can embed a Python interpreter into it. Can you write an extension module that embeds a Python interpreter into a Python interpreter? And apparently you can't, but I found a way to do it. Now, by the way, before I show you how I did it, because I did it in a couple different ways, somebody at the end of my talk asked me, why do you want to do this? And I told them, because somebody said you couldn't. And I actually came up with this idea during office hours. I think Andy can attest to it. This is something that I developed during NYC Python office hours, which is the reason why all of you should show up. There's a lot of really cool stuff going on. So here's the latest approach. And the latest approach is very simple. The first approach was just try to embed a Python 2 into a Python 3. And you can't do that because when you try to compile your extension module, the Python 2 and the Python 3 symbols clash. So I wrote a source filter so that all the Python 3 names had Py3 appended to the beginning of them, and then you could do linkage. But I didn't like that because it requires you to essentially modify an enormous number of files in Python interpreter. Well, it turns out with DLSim, and this was really suddenly I didn't realize I hadn't figured this out before, but it turns out to be really easy. With DLSim, you can do this little thing called, where is it? RTL debind. What this means is, in a Python interpreter, you can go and you can load shared objects. You can load other libraries. And one of those libraries could be another Python interpreter. And you can load it dynamically in such a way that the names in the library are not visible and do not conflict with the names in the program that's loading. So that's what RTL debind means. It means that the loaded shared library should only resolve things where it's resolving them internally. What this allows you to do is to create a C program that embeds multiple Python interpreters. This is an example of embedding multiple Python 2 and multiple Python 3 interpreters in the same process. So here I have 2 or 3 Python 2s and 2 or 3 Python 3s running the same process. Unfortunately, it requires me to copy around shared objects. I have another version of this I'm working on where you patch your linker so you can load shared objects multiple times. And I'll show you something really neat that I came up. This was on the flight back. Something really neat that I had to come up with. I wanted to, the end goal of this was to embed a Python 1 into a Python 2 into a Python 3. But you can't embed Python 1 because nobody's ever built a shared object for Python 1. So I think I'm the only person who's ever built a shared object for Python 1.5. It took me about half the plane ride to fix the makefile so you could actually build a shared object. And then I was able to build a Python 1 embedded in Python 2. But the step to get that embedded into a Python 3 is still a little bit loose. So there you go. I've given you 6 really bad ideas, all pretty much on theme. There's a couple other really bad ideas that I posted to the event comments. And I wanted to talk very briefly about why. And there's a real answer for this. I have found that when you're programming, there is enormous advantage to testing the boundaries, to going as far as you possibly can. And the results of that may be ridiculous things like this, like Python interpreters embedded into themselves. Who would ever need that? Or live patching the interpreter. Or creating an import hook that returns different results based on who's doing the import. However, what I have consistently found is every time you push the boundaries, and you go a little bit too far, and you do something that man was not meant to do, you learn something deeper about the system, and you pick up techniques and tools that end up actually being useful and effective for real-world problems. So each one of these cases, I found there's always an opportunity to use the knowledge that I've gained in order to solve a much less ridiculous or much less provocative or much less pointless problem using the same techniques. I wouldn't know how to solve those problems. I wouldn't know how to use import hooks to do some of this surgical import trickery if I hadn't gone all the way. And so I would encourage all of you to test the boundaries, to see what you can do and what you can't do. Knowing what you cannot do is also extremely beneficial because finding these real barriers in the language. I'll give you a better understanding of how the language works, how it's structured. It gives you an understanding of what is possible or what is easy to do or what is hard to do. And I think it makes you a better programmer in general. So that's my motivation for this talk. I think I've shown you a couple of really, really bad ideas. I'll recap them very quickly. Here is, don't write everything in one line, please. But here's how you can if you want to. This is some trickery with the syntax, using yield from where it doesn't belong. This is playing with the CPython interpreter and just mucking around and seeing if things compile, and doing things like lambda decorators and returns outside of functions. This is playing with the mechanisms of Python in order to build higher level mechanisms like typed generators that can then modify their own computations at runtime. This is using some of the safety valves that Python gives you in order to implement very strategic and very surgical changes to the language, namely mucking around with the import mechanism. This is just a bad idea. But this is how you can actually modify the currently running interpreter, and some playing around, or some initial playing around with what the interpreter is doing at runtime, and also a little bit of bytecode trickery as well. And finally, this is the solution to the Jill. Instead of multiprocessing, just embed multiple interpreters into the same process. There you go. This is playing with some of the notions of what shared objects are, what dynamic linking is, and how things work in the actual really C level. So that's my talk, that's my motivation. I hope you enjoyed it. I want to hear from you guys. I'm sure you've tried and run some of these things yourself. Thank you. Any other questions in the front?
The C, Python, interpreter. I think there's a useful case when you want to do the PyCoda, Python interpreter to Coda programming. The Coda is very difficult to program. So I think if you can modify the kernel, instead of interpreter will be efficient.
So there's a suggestion that one of these might be good and not a bad idea. I'm skeptical. However, it's true that some of these things, like modifying the current interpreter, may allow you to deal with situations where you're embedding Python or where you have to communicate with other processes. Was there another question?
Yeah, your one-liners.
Yeah.
One-liners are just like,
Don't.
I love one-liners too, but I find that my fellow programmers have like a really hard time reading through them and understanding.
That's the point. That's what's so great about it. Nobody can understand what
That's
you.
what we need to do is we have to insert a lot of comments now. To explain them so that it's one line. It's not going to become two lines.
Here's a great thing. Insert comments that are wrong. And then really confuse people.
It takes a long time for sound to get all the way down here.
Oh, yeah, there you go.
Have you considered writing a Python obfuscator?
I consider that would put me out of a job if I were to write a Python obfuscator. But you're right that maybe you could use it to obfuscate Python in some ways. I would imagine that somebody would just take the bytecode and then decompile the bytecode back into Python. You wouldn't really gain too much.
Something like that.
Yeah.
It's like Dropbox and that's that there.
What you could do is you could write a obfuscator that patched frame eval so that the C eval, so that the actual evaluation loop did different things, and you added your own bytecodes. That would be really, really hard to understand what it did. So, is your company hiring? No. But you could use these techniques to write maybe obfuscators or minute flyers. I don't know that would be terribly useful. Yeah.
Just a thought. Years ago, there was a language called APL. I don't know if anybody heard of it.
Oh, yeah.
It was a beautiful, crisp language, somewhat like
With issues.
what?
With
Somewhat
issues.
like Python. The syntax was very elegant, and it was invented by a mathematician, and I understand the language of thought. And you could write an extremely elegant program in one line because it was just symbols, and it was touted as a write-only language, meaning you thought of something, you would write the program, but no one could, including yourself, could ever read it. So,
Yeah, there you go.
there you have a good idea.
And one nice thing about Python is that it's intended to be a language that you should be able to read, and people should be able to understand without having to spend too much time or too much fun. It's supposed to be very easy to read. But you can see even in some cases that may not necessarily.
How did you start out like pushing the boundaries of the language like you've been doing? Like, these seem like to be the result of like quite a lot of time spent sort of pushing the language or pushing the boundaries. Like, what were some of the first things you did?
So the first steps for this were, one of the first steps was a friend of mine was interviewing for a job that needed Python. So he asked me, how do you write, it was a Knight's Tour. I have this on the computer. He said, how do you write a Knight's Tour in Python? And I thought, well, here's how you can do it in one line. just to play around, right? I mean, you're kind of curious, and these are problems that are hard in interview. So when you have time, when you have as much time as you want, they're not that hard to do. You just look through, Wikipedia page and just implement it. And so some of the challenges, how can you do it better or shorter or more obfuscated in one line? And I find that one-liners tend to be a challenge, especially in Python. How do you express things in a single line without driving yourself down? Then I got bored of one-liners. I thought, this is too easy. So I went to, I think from one-liners, I went to syntax, mucking around with syntax, to see where I get the syntax. And then I got bored with that, and I said, well, let me play with the interpreter. And then I'm kind of getting bored with the interpreter stuff now, so I think I'm going to go do some mucking around at the assembly level. And then once I get bored with that, I might just destroy the world. So I don't know, but it was essentially seeing just curiosity and a little bit of idle time. I've idle time. Were there any other questions? Do y'all enjoy seeing some of these things?
We did.
Okay, I might post some of these online if the government will let me, but there are export restrictions on these pieces of code, so they may not be available. I wanted to thank all of you for coming out. I have to leave very shortly. I think it was an awesome night. We heard an awesome talk from Allison. I think we're going to hear from some of you in the audience right now. I wish I could stay to hear from all of you guys, but I really want for you to share some of your experiences and some of the things that you've tried to push the boundaries or some bad ideas that you've implemented. Thank you very much. I'm going to